Computers will be able to recognize and solve product measure problems. So product measure problems are going to be a slight departure from what we've been doing in terms of what a product measure is. It's not going to have rates involved with it, but it is going to be solved the same way. We're going to be using dimensional analysis and paying attention to the units to solve these product measure problems. When we talk about product measure, the word product, that means the answer to a multiplication. We're going to be using units and measures that are units multiplied together. So as we read this first problem, it says, Javier's soccer team is building a shed to store all of their soccer equipment. They estimate it will take 30 man-hours to build the shed. This is our product measure. Right here. This man-hours. And when we see this hyphen, that's going to be a dead giveaway of a product measure. We're also going to be able to think of that hyphen as a multiplication. So we're thinking about this as being 30 man-hours. 30 man times hours, or persons times hours, or soccer players times hours. Whatever it is, some unit of human beings times hours. So what this really means is there are 30 hours of work that needs to be done. Judea can do 4, I can do 4, Rogelio can do 4. People around this room can do sets of those hours, and we can distribute it up until it's all done. Okay? So what we're trying to do is we could figure out how many hours it could take or how many men it could take if we know the other. So if I had 30 hours of work left to do and it was just Judea and I, how much work would we have to do? 15. Okay? If we had 30 hours of work to do and it was Judea, me, and Brenda, how much work would we each have to do? 10 hours. So you guys kind of have this idea. Okay, well, let's say we have it this way. I only want to work 3 hours, and we've got 30 hours of work to do. How many other people do I need to get? Yeah, so we have to have a total of 10. That's how man-hours works. Man-hours, I think, is the one that is the easiest to explain to you. Okay? So when we think about it, we figured out how to do that by multiplying the number of people times the number of hours. That told us how many total man-hours we had to do. That's a product measure, all right? So when we see this problem, we're automatically going to recognize that hyphen, splitting up those units. That's a product measure. That tells us this type of problem is going to be a product measure problem. It's going to be a dead giveaway. Every time we see that hyphen, well, not every time we see that hyphen. When we see that hyphen splitting 2 sets of units, we know that that is a product measure. Now, does a hyphen have other uses in the English language? Absolutely. So every time you see a hyphen, it may not necessarily be a product measure, but there's a pretty good chance. Just check what's on both sides of those hyphens. If it's splitting up a word that got cut off on the end, all right, that's obviously not a product measure, right? But if it's splitting up 2 units that you know, like people in hours, or pounds and inches, or feet and seconds, or something like that, it's a product measure, right? So as we come through and we continue answers, it says, how long will each person need to work? So we start with our answer sentence. Each person will work blank, most important part of all of our work. What goes on that blank? Units, which are in this case hours. Tells us we can go ahead and start setting it up. We know our answer needs to be in hours. We're going to find the information that was given to us. So we recognized this product measure problem earlier. So instead of writing a rate, I'm going to write PM for product measure. 30 man times hours. And the other information that's given to us, it says 4 players. Now, in this particular problem, whenever it says man or person, it's talking about human beings. So when I write down the units for these 4 players, I'm actually going to write them down as 4 men. Putting that in quotations, 4 human beings. It doesn't really matter. When we're talking about human days, human hours, whatever, just talking about human beings that are going to do the work. All right. So here we come up with a slightly different situation than we've seen before. I've got hours that I need to have on top of my answer. Looking at the information I have written down, what is the only way that I'm going to get those units on top? Kevin.
If you put the 30 divided by 4.
30 man times hours. That gets me my hours on top. That's absolutely what we need. Now the second part of this unit is once you get your units matched up, now you need to get rid of the extra units. Well, I'm only supposed to have hours on top, but I've also got man up here or men up here. What can I do to cancel out those extra units? Judea?
Put 4 men at the bottom.
Put our 4 men at the bottom. Our units tell us men cancel out with men, which tells us that this problem is a division. 30 divided by 4, and we should get 7.5. So while we have a conceptual idea of how man hours works, and we probably could have figured out that this was a division problem, it was the units that checked that work for us. Because we're going to run into some other product measure problems that are not going to be as intuitive, things that you may not know about, okay? So as we look at this, we're going to define a product measure really quickly. A product measure is a measure of 2 units multiplied together. And they are written with a hyphen. And I'm going to put in quotation marks that a hyphen is that dash. So that's how we're going to recognize product measures when we see them in problems. We're going to see 2 units multiplied together. They're going to use that hyphen instead of a multiplication symbol to show us that that is a product measure. So some examples we've already seen: man hours or person hours. Foot pounds. That is a measure of torque, which is how much it takes to, which is how much power it takes to twist something, depending on how far away you are from it.
Torque.
You may see things like kilowatt hours.
Kilowatt hours?
Yep, kilowatt hours, which is a measure of how much power you're using or how much energy you're using, okay? There's some other things like Newton meters is very similar to foot pounds. Horsepower hours, also very similar to kilowatt hours. Just measures of...
Dogs pounds, right?
So, we've got that. So we're going to flip on over and we're going to look at our last 2 examples for today. It says a Newton meter. That looks like some given information. This looks like a product measure. Newton meter is the amount of energy required to lift 1 person, or lift 1 Newton up 1 meter. If I'm thinking about that, I'm going to think back to that. That looks like that's important information, but I may not actually need to know that. It says if 12 Newton meters were used to raise the stone that weighs 6 newtons, how many meters was it raised? So I'm going to start here with my answer. How many meters was it raised? It was raised blank meters. So I see in here definitely that this looks like it's going to be I see that hyphen, that this type of problem is going to be a product measure. And I see information given to me here is 12 Newton meters. So product measure given to me is 12 Newton meters. And a link to that 12 Newton meters is this situation that something is weighing 6 newtons. So that looks to me like that should be enough information to answer this question, which would suggest to me that the rest of this is all just a distractor. We'll test that here in a second. So we're always starting again with the units of our answer, should be meters. And what is the only way that I'm going to be able to get those meters on top? What's the only piece of information that I have that's going to get those meters on top? Raven? Yep, 12 Newton times meters. So that gets our meters on top, but what we recognize is that we've got these extra newtons, these extra units on top, so I need to find a way to cancel them out. We're very fortunate here. We do have newtons in our situation, so I just need to figure out where I need to put it to make sure that it cancels out. Viviana? Yeah, and I need to put it under. That's going to allow my newtons to cancel out with my newtons. Checking my units, I should have meters left over. I've got meters left over. And it tells us this is a simple division problem. 12 divided by 6 should be, it was raised 2 meters. Okay, simple. The units lead the way. Now this next problem is going to be slightly different. As I read through this, it says Maya is trying to break into Mr. Boots' room after school to steal his homework. She is trying to pry the door open with a 2.5 foot long pry bar. If she was able to put 120 pounds of force on the end of the pry bar, how many foot-pounds of torque can she create? So what we're going to recognize different about this one is the second we start writing our answer sentence, it says how many foot-pounds. So in this case, our answer is going to be the product measure. She can create blank foot times pounds. So this is still going to be a product measure problem. However, in this particular problem, we're not being given a product measure. We're being asked to solve for a product measure. So this is a lot like solving for a unit rate, except for it's with product measures. So we need both of our units on top together. So we're given a situation of 2.5 feet long and 120 pounds of force. So I want to pay attention to my units here. I need feet and pounds on top. Leslie? Yeah, just put them all together. So 2.5 feet. Thinking about it as we need it as a foot times pounds. So 2.5 feet times 120 pounds. Okay, we need feet and pounds both on top. That's exactly what we've got. We've got no extra units anywhere. This is perfect for us. So all we have to do in this particular problem is multiply 2.5 times 120. So 120, 2.5, 0, 0, 1, 6, 0, 0, 4, 2, 1 decimal place. So it looks like I get 300 foot-pounds. So the question came up last period, well, hey, Mr. Boots, how do I know whether to multiply or whether to divide? Well, how do we know whether to multiply or divide? What guides us to recognizing this is multiplication or division? Kyrie?
Because the answer is you have to put it in product measure, which is multiplication. And when you're dividing, well, you're using product measure as your problem.
It's part of your problem, and those units have to cancel out somehow, so you end up, it's the units that lead the way. All right, key points. Perla. Yep, look for a hyphen separating units to recognize a product measure. Leslie. That works for if we are given a product measure, but if we're asked to solve for a product measure, it's going to be different. So more globally, we can maybe come up with a different key point. Kyrie?
What?
If product measure is in the problem, it's multiplication, and if it's in the answer, it's division.
Even more global than that. Janaea,
Wait, what? Wait.
what do you want to say? Tell me what you want to say.
I was about to say that, but a little different.
Tell me how you were going to say it.
I was gonna say make sure that you know that when this hyphen has the like Newton meter without. I can't describe it, but it's multiplication.
Okay, so what I'm going to say is make sure you know the units of your answer. And you set up the given information to cancel out the units to get those answers.
That's too much to write.
Start with the units of your answer. Here, I'll even cut it down. Start with units of answer. Set up given info. How do you like that? Info to cancel out to get. Then instead of writing the units of your answer, we'll just draw an arrow to that. All right, so we always want to start with the units of our answer and set up the given info to cancel out to get the units of our answer. That's this entire unit wrapped up in one key point. This is our entire unit right here. It's pretty much every problem that we've done this entire unit. There are some small subtleties in those different problems, but that's our entire unit. If you start with the units of the answer and you get the given information to cancel out to get those units, you're going to be set. All right? Any questions about our work? All right, flip over to